Okay, so Charles' law. Charles' law is about gases, and it essentially says the volume is proportional to temperature. So as you heat a gas up and its temperature increases, its volume will also increase. It gets bigger, it expands. Whereas you make a temperature of a gas colder, its volume will decrease, it will actually shrink. So you can think about it like a balloon. If I blew up a balloon and then if I put a hairdryer on it and started heating up, that balloon would actually get bigger as it got hotter. And of course, if I kept going long enough, it would break the balloon and it would pop. And so we're going to try to measure that volume change between a hot and a cold gas and see if it correlates to the predicted change that you can actually calculate using Charles' law. All right, so let me go through the setup first, and then we'll actually do the experiment. Here we have some boiling water. This should be at approximately 100 degrees Celsius. That's the first thing we'll do is we'll measure that. So with our boiling water, I'm going to take my thermometer, turn it on. Room temperature looks like it's about 23, 24. But let's take the probe and put it into our boiling water. And it looks like the boiling water is just under 98. We're going to call it 97.7. You want to record that on your sheet as the hot temperature. As the hot temperature. Similarly, here we have a bucket of ice water. There's ice in here with water, and so this should be about 0 degrees, maybe just a little bit colder than 0. Yeah, it's very cold in my hand. All right, so let's take our probe, we'll put it down into the ice water here, and we'll see what it's measuring. You can see that on the thermometer. You want to record that as the cold temperature. All right, so we've got our hot temperature and our cold temperature, and for the rest of this experiment, we're going to assume that that's going to pretty much stay the same. It's not going to change between the hot and the cold. Now, where's the gas? The gas is the air. Air is a gas, right? It's a mixture of gases, but it should obey Charles' law. So the air is what's inside this 250 milliliter beaker. Now this is the air. We're going to take this and submerge it into the boiling water bath. That will heat that air up. Now we know what's going to happen. As the air gets hotter, it's going to try to expand. Unlike a balloon, this glass is not going to blow up. So instead, as it expands, the air is going to push out of this tube, and we're going to put this down into this second flask of water, and we should see it bubbling out. We should see it bubble, bubble, bubble as the air gets pushed out. We're going to let it sit in there for about 5 minutes. That way it'll make sure that the air all comes up to that hot temperature. And then we're going to take this out of the hot and plunge it down into the cold. Now you think about what's going to happen. As the air gets cold, it's going to shrink. But again, the glass can't shrink. So instead what it's going to do is it's going to suck the water back out of here, and we should see the water come dribbling down into here. And the temperature of the cold air, I'm sorry, not the temperature, the volume of the cold air will be whatever's in here, the volume of the whole flask minus the volume of the water that gets sucked back down into it. In other words, let me put it a different way. The total volume of this flask, some of it will be this water that got sucked back into it, and then the other part will be the air. And so we can calculate the volume of that cold air by subtracting the two. All right, so before we actually do this, as I described, what's very important is we find out what is the volume of the air in just this normal flask. What is the actual volume? It's a 250 milliliter flask, but that doesn't mean if I fill this up with water right to the bottom of that stopper, like when I put it in, that doesn't mean it's exactly 250, does it? You know, it's an approximate volume. We need to know what it really is. And so let's do that first. Let's take this flask and figure out what is the true volume of it. And we'll do that by coming over here and filling it with water. This is just normal DI water, nothing special about it. Again, we're just using this to figure out the volume of the inside of this flask. All right. And then we're going to put, again, we're going to have this tube going down, you know, with the stopper. So to stimulate that, I'm going to take another stopper, I'm going to put it in, and some of it dripped down, that's fine. All right, so there we go. Whatever water is trapped in here now, right, there's no air, this is all water in here. The volume of that water that's trapped in here right now is the volume inside of this flask. I don't care if it's water, or if it's air, or if it's Jell-O. That's the volume of that flask, right? And so let's find out how much water is in there right now, and that'll give us the volume of it. So I've got my large Erlenmeyer here. Let's go ahead and take this and pour it over, and we'll see what is the volume of this flask. Okay, and I will let you zoom in there with the camera, and they can read the volume. There we go. Move it there so you can see it better. And you should record that volume on your sheet. So we've got the hot temperature, we've got the cold temperature, and now this is the volume of the flask, which on your sheet I believe is called V-hot. Okay, here's a close-up of the volume of that flask. So we've got it in here. Let me wiggle it so you can see exactly where that water is. And the 250 mark and the 300 mark is up here, so you can figure out exactly the volume of that water. And there it is. Okay. So that is the volume in the flask. In this flask, which we have now totally dried out as well. And so we won't have any interference from any little droplets of water. Great, so we're ready to go. We know the volume of the flask, which again on your data sheet should be V-hot, is the way that's described. We'll go ahead and we'll put the stopper in. And so right now the air that's trapped in that flask is what we just measured, that V-hot, that number. The other side of this tube, we'll go ahead and put that down into this water here. And then I'm going to go ahead and take this, clamp it up here. Clamp that in. And we're going to plunge this Erlenmeyer now down into that boiling water. So I'll just take it and push it right on down in there. The whole idea here is we are heating it up. And look at what's happening over in this flask. Wow, it's really bubbling up quickly. What's happening? Again, the air is heating up, it's expanding, and because the glass can't actually stretch out, it's pushing through the tube, and it's coming out here instead. And it's still getting hotter and hotter. You still see it bubbling really quickly at first, but what we want to do is we want to heat it up until this stops bubbling. Might take about 4 or 5 minutes or so. At that point, we will know that the air inside of this flask is T-hot. It is the temperature of the hot water, which we recorded earlier. All right, so we're going to give this a couple minutes until this stops bubbling. Okay, it's been about 5 minutes now. This is not bubbling anymore down here, which means the air inside there has come up to the temperature of hot. You know, what we measured as hot. So the next, we're going to take this, I'm going to take it out of there and plunge it into the ice water. All right? And I'm going to bring this, I'm going to keep it down in the water, the tube, just so it doesn't stretch too much. When I plunge this into it, of course, that's going to cool off the gas inside of there. It's going to suck the water, hopefully, if it works, up through this tube and down into there. All right, so there we go. Let's find out. I'll go ahead and unscrew this so I can take it off. And there we go. Up here and plunge it down into here. Oh, yeah, I don't know if you can see that or not. But it is dripping away right now. Can you see that? I don't know if you can see the dripping or not, but it is definitely dripping away in there. Well, here's the proof. Look at that. Look at all that liquid that's down in the bottom now. That all got sucked over. So what we're going to do is we're going to leave it down into here. There's the drip that just went through in there in the top. We're going to leave it like this until it stops dripping. And measure the volume that got sucked over. So just like we let the temperature come up to the hot in the boiling, now we got to let the temperature come down to the cold in the ice water here. I haven't seen any more drip over here.
I don't
And
see
so
it
I'm
there.
thinking,
Maybe it's
we're probably pretty good here.
Uh-huh.
So, I'll take that off.
Uh-huh.
Here's the water that got sucked over. That essentially is the change in volume then. That's how much it has changed when we went from the hot to the cold, or actually vice versa. Oh, that was right, from the hot to the cold, yeah. It decreased in volume, and how much did it decrease by? Well, that much. Let's measure it. An easy way to measure this is by taking the graduated cylinder, just like we did with the flask. And this has got white numbers and a white background, so that's not going to work. You might actually be able to see it better against just a black background like that. Let's go ahead and pour this in, and we'll see what was that volume change. Try to get all of it over there. All right. I'll let you zoom in with the camera. Move a little bit so you can see where that water level is. And you could record that volume. Okay. So now we've got volume hot, we've got volume cold, we've got temperature hot, temperature cold, we've got volume hot, and by subtracting the difference, you've got volume cold. All right, and that should be all there, right there on your data sheet. You'll also use Charles' law to predict what that volume cold should have been, and then you can get a % difference if you want. So at this point, we just need to repeat this twice. We need 3 trials total, so we're going to go through the whole process 2 more times. We've got 2 brand new beakers that are already nice and dry, and so we'll set this right back up and do it twice more. Luckily, we've already got boiling water over here. We might need to add a little bit more just to bring it up. That'll come up to boiling pretty quickly here. I'm going to go ahead and top this off as well. Make sure there's plenty of water here. Okay. And the first one. Exactly the same setup as before. Just waiting for that to come back to a boil. I'll get it set up while we're waiting. Okay. It's starting to boil a little bit at the bottom. I don't think it'll take too much longer. As soon as that water starts boiling in that water bath, we'll put that beaker down. And again, we know what we expect is that gas expands, it'll push through here, and we should see a bunch of bubbling start in our flask over here. Close. Neither hem's red.
Okay.
Okay, so it's starting to boil. I know it'll get a little bit more going, but I'm gonna go ahead and plunge it in because it's gonna have to sit for 5 minutes anyway to allow the gas to come up. So let's go ahead, we'll drop it, and we'll watch that come bubbling out over here because of the expansion according to Charles' law. So here we go. And down into the hot water goes. And look at that, bubbling out. Beautiful. Okay, we're going to let this come up to the full boiling. We'll let it go for about 5 minutes. That'll stop bubbling at that point, and we'll transfer it into the cold water. So, 5 minutes. Okay, we've been waiting about 5 minutes here. It's definitely come up to the full boil, and this maybe has one little more bubble that's trying to form. I think there it comes. All right, I think we are good. So it's gotten up to the full temperature. We'll go ahead and plunge it into the ice. Again, it'll suck that water back out here into the flask when we do so. I'm going to bring this around here, make sure that stays down in the water, and maybe loosen this. Okay, and we'll see if you can see the water come sucking over when I do this. So out of there and then into here. And here it comes, and there it is. It's being sucked right through there now. It's really dribbling quite quickly out of there. As we, again, that might be hard to see on the camera. And it's slowed down a little bit, but it's still dripping down there. You can see the water just coming out of the hose. So I'm going to go ahead and push it all the way down. And again, as evidence, look at all that water that got sucked over already. So we're going to go ahead and leave it down there. Make sure that that air gets totally cooled off to the cold temperature. We'll leave it down in for a couple minutes. And then we'll measure the volume of it. And what I'm doing is I'm kind of watching right in this area to see if I see any more drips come through, any water, and I haven't seen anything yet. You might be able to see there's a little bit of a bubble right there too, and I haven't really seen it move, so I think we're just about there. We'll give it a little longer, just to make sure. There was one more. It's just dripped down. Okay, so let's go ahead and set this aside. We'll take this clamp off. Okay, again, the volume of that water was the volume change of Charles' law. That's how much it shrunk when we put it into the cold, and we just need to get an idea of what that volume is. Make sure there's nothing left over from the last measuring. Let's go ahead and pour it in here, and we'll see what that volume is. All right, there we go. Oops, I measured on the right scale.
They have to read the backward, huh?
Well, let's see, this one's going up 20, 30,
Oh,
40,
okay.
50, so.
Okay.
I think maybe in the first round, maybe we had the other scale.
The other scale. Yeah.
So
Uh-huh.
they'll have to just
Sure.
think about what that means on the scale. I apologize for that, but it's a 100 milliliter graduated flask, so you can just subtract it from 100 if you think about it like that.
Okay.
And before we stop here, this flask that we just used, it might have a slightly different total volume than the one in the first trial. And so let's go ahead and measure the total volume of this flask, just like we did before, by filling it all the way up. Up here, putting the stopper into it. Yeah, that's the one with the hose. Where did our black one go to? I've lost my stopper. Well, here's a green one that's the same size. It's just green, so it'll work. That's fine. Put that in. It spills over a little bit. That's fine. Yeah, I don't know what I did with my black stopper. That's kind of funny. Okay, and so there it is. There's the total volume. Take the stopper out. We'll go ahead and pour it in here, and we'll see what the actual volume of this flask is. Okay. There it is. Again, I don't know if a white background or black background is better, but there's the 250 line. There's the water line. Okay. Okay, one last time, trial 3. And we've got one. Oh, there it is. Thank you. We found our black stopper. Okay, one last trial. So let's just come over here. We'll set it all up again. Let's see. Make sure that we got enough water in here. Take our third flask, stopper it up, clamp on. Here, and we'll go ahead. I'm going to plunge it down right away, I think, on this one. There it goes. There's the bubbling as usual. And since we have to wait for it to come up to temperature anyway, I'll go ahead and add just a little bit of water, although it's pretty much buried. Now just add just a little bit more, just to make sure the whole flask is it's submerged. And as usual now, we'll wait for this to come up to temperature. We'll wait for that bubbling to stop over here. Take about 5 minutes. Okay, it's been about 5 minutes. This bubbling has almost stopped. It's still going a little bit here. We're going to go ahead and move it over to the cold as usual. So there we go. Get it out of here and put it over here. I'll try to lift it up just a little bit so it is dribbling down there. It is literally a stream pouring down there right now. Hard to see. Now it's dripping a little bit more, but it is definitely sucking that water. And let's see. Oh yeah, look how much has already come in. All right, so we're going to put it all the way down in there and hold it for a couple minutes to cool it all the way off. I don't see any more coming over, so we'll go ahead and measure the volume now of that liquid that got sucked over. Okay. All right. Okay, and then as usual, the last thing we need to do is measure the volume of that flask that we just used. Fill it up with water. All right, with the stopper, a little bit dripped over, and so now the water that's in there is the volume of the flask. Let's see what that comes to. Okay. Does that help to do that? Shake a little bit so you can see where the water level is.